All you have to do is give me this. If you wanted to graph that on your y equals, you could, and make sure the center is there at least, and that would tell you that you had the right one, because you're just going to put it in y equals format. Then you don't have to resolve this part. So if you want to just put the asymptotes there, you'll see that the center is there. But, okay, questions? How do we know this is a hyperbola? Because there's a minus sign here. There's a minus sign. Okay, that's the hyperbola. The center goes the same as all the other ones do. H goes with the x, y goes with the k. It matters who comes first in subtraction. So this guy is always A. Again, did you have a question?
How do you do the asymptotes?
Asymptotes are easy. They look bad. Take the y, because normally you would say y equals. Take the y guy, whatever is hooked up to this thing. Okay? And it's going to be plus or minus, because you got two of them. Plus or minus a slope. A slope is always change in y over a change in x. So come to the y, take the square root of that. Right? 1. Come to the x, take the square root of that guy. 2. And then just put the x one. Now, all you have to do is get this to say y equals. So just subtract the 2. You can leave this for me. I don't need you to resolve this out. One with the plus, one with the minus, and then distribute. I don't need you to do the rest of that. And again, if you put this in your calculator, these two ones, you'll see that they cross, or you should see that they cross right at the center. Yeah, that's a good way to check that you have this. The formula is a little confusing because you have to know which one is the A, which one is the B.
Wait, so the slope is y over x, like the square root of b
Square
over
root.
the square root of a?
Or it could be the square root of A over the square root of B, because that's going to change. Because what's happening is this. A and B stay here. Your x and y change. That's why I don't want you to say A and B. Because what happens in another one, well, this one's still first. What happens when my y is first? Then my y is A. So I don't want you to do A and B. I just want you to do change in y over change in x. Because what happens to that denominator is it will change. It could be A and B, or it could be B over A. So rather than think that, think your slope. You know how to do a slope? Change in y over change in x. So find the y, come down here, take the square root. Find the x, come down here, take the square root.
How do you know by looking at the asymptotes that you're
I don't know by the asymptotes. I know by who comes first. Whoever comes first, if the x is first, it's going off the x-axis. If the y comes first, it's going off the y-axis. Your foci, again, are outside of this parabolas. Outside of them. So therefore, that's why we do the c squared equals a squared plus b squared. We need it outside of it. Everybody else okay with this? Technically, not to list them, but to find them to make the box, yes. But do you have to list them? Because they technically don't exist, but we do need them to find this box. So,
how do you make the box?
you find, okay, so let's take this one. Which one is going to be the major axis, the x or the y? The x, because x comes first. So whoever comes first in the subtract is the leader here. So I'm going to go off the x-axis. So underneath this guy is the A, because the A always comes first. Underneath this guy is the B, because the B always comes second. So now, I know what my A is, square root. I know what my B is, square root. I can find my C. Can we find all the pieces? Can we find ABC? Okay. Once you found ABC and find the center, what's the center of this guy? Negative 3, 2. So I'm at negative 3, 2. God bless you. Just translate your axis like this. So negative 3, 2 says this. The major axis is the x. I'm going to go over 12 this way. 12 this way. So this is negative 3, 2. Let me just write this here. So if I go over 12, that's 3 and 9 more. So this guy is 9, 2. With me?
Yeah.
If I go over 12 this way, what am I at? Negative 15, 2. Okay, that's part of my box. Now B is the other part. B is 5. I'm going to go up 5. So I'm at negative 3, 7. I'm going to go down 5, which is going to put me down here. So I'm going to be at negative 3, negative 3. Technically, that's a covertice, but it really doesn't exist. Just to make the box. This is your box.
I don't know which one to go for.
Because you have to look to see that A is always the first one. Who's first? X. So off your translated x-axis, you go A. Off your translated y-axis, you go B. God bless you. So now, this is my box. This is my box. My asymptotes go through the corner, and I'm kind of like a little makeshift thing over here. My asymptotes go through this corner. And my hyperbola is going off the translated x-axis. So this is my x-axis. So there is its little vertex. There is the other little vertex. There's my hyperbola. Now, question? Annie?
How do you know like how wide that opens?
Because of that box. Whatever, you just follow the asymptotes. Like you just follow along. I should probably be a little closer to mine, but as long as you're in this range, that's fine.
So it's like really close, but doesn't touch.
Doesn't touch it. They're asymptotes. They're guidelines.
Okay.
Now, watch the equation of this guy. Watch. I'm going to take, watch guys. God bless you. I'm going to take my, this is my slope, this is my x. Start like this. Just start like this. Y equals slope x something, right? Don't we say mx plus b? So I want the m and the x part. Now, my slope. My slope is the change in y. How far was this guy? How far was this? From 2 to 7, how far was this? 5. I went up 5. I went over how far? 12. That's it. So we say, whatever underneath the y, take the square root. There's my 5. Whichever underneath the x, take the square root. There's my 12. Make sense? Don't do A and B because here's the problem. This guy, the x comes first. It's under the A is under the x. If the y comes first, the A is under the y. So the A and B have to switch. So in your formula sheet, it says y denominator over x denominator. Don't worry about A and B. Just take the y denominator, take the square root. How many of you actually use that note sheet to do this? That's going to help you. You got to use this. The y denominator over the x denominator. It can't be more simple than that. It's the slope of a line. And then all I need you to do is just say plus 2. Just get that 2 over there so it says y equals. I'm not even asking you to distribute, do your slope, multiply. I'm not asking you to do that. Now if you graph those two lines in your calculator, you will see that they cross at this point, where your center is. So the hyperbola kind of has a center, if you can call it a center. where everything is going to be equal distance from that, and they have vertices for your little, like, parabola parts. And the foci have to be off of the main one, C distance away from here. So my C was 13. So if I add 13 to this guy, I will get over here. So that puts me at 10. 10, 2. That's a foci point. And then just go the opposite way. So try not to use your formulas. Try to get a feel for this. The way I like to look at it is, on the ellipse, does it matter what order I add in? No. So it doesn't matter who comes first in my ellipse. So placing A under the first guy or under the second guy does no good, because I can put them in either order. So on the ellipse, whoever's the larger one is A. In a subtract, it matters which way I set it up. 5 minus 3, 3 minus 5. So the first guy is going to be the A. He's the major one. Because in ellipse, I can swap, but in hyperbola, I can't. And your circles too, you can change. Which is, we get so used to looking at this format, and everybody always expects to see this. But I can do this. It's commutative property. I can do it either way. Okay? But in a hyperbola, I can't. Alright, so now, completing the square doesn't really do anything for us because we don't have any other terms there to complete the square. So it is already set up for a hyperbola. I see an x squared, I see a y squared, and I see a subtract sign. So therefore, everything's to one side, I divide by 6, and I got my little hyperbola going on. Who is the major axis? The x, because the x comes first. So A is the square where A is underneath my x. It's first. A is radical 3, B is radical 2, you can find out C. Now, my center is at 0, 0. Again, my center is at 0, 0. X is my major axis. So radical 3 is like 1.7, so I go here. 1.7, I go here. If I go up radical 2, it's just a little bit more than 1. That's my covertice. This is my box. These are my asymptotes. My parabolas go off of my vertex as close, like I use this as a guideline. I use it as a guideline. Okay? And you should be able to find your vertices and everything, because you're at the 0, 0, so it's not so bad. So 0 for my vertices moves me radical 3, 0, and negative radical 3, 0. If you want to write it plus or minus radical 3, 0, I am perfectly fine with that. This one you're moving up to, a radical 2, sorry. So 0, radical 2, and 0, negative radical 2, which you don't really need to list these guys. You just need that for your box. Your foci is out here. It moved radical 5. And this foci, negative radical 5. Let's see if we could do your equations of the lines. So y doesn't have anything to hook it up with. So it's just this. So this is the place I'm going to start. Agree? Because there's no parentheses thing. So my slope is the change in y. So I go underneath my y, and I say take the square root. I go underneath my x, I take the square root. Luckily for you, that's all you have to do. You can put it like that, or you can put it under 1. You don't have to resolve your radicals. And isn't this so? I walk up y, that's radical 2, over x, that's radical 3. That's my slope. Don't get hung up on A and B. Do whatever under y, whatever under x. Questions? Are we feeling a little better? Okay. I know that equation of a thing has a fraction in it, so it probably throws you off. So complete the square. We know this is a hyperbola because we have an x squared and a y squared and a minus sign in between. So we group together our x's, we group together our y's. Now, be careful of this. When you complete the square for y, the coefficient of y has to be 1. Right now the coefficient of y is negative 1. So you have to factor out a negative. Did everybody remember to factor out the negative 1? Because that's your rule. When you do complete the square, your leading coefficient has to be 1. This guy is a negative 1. So I have to factor out this negative 1. So this is going to change that sign too. And when I distribute this out, I'm going to be distributing a negative 1. Your leading coefficient has to be 1. Okay, so you're going to complete the square. You're going to divide. The x's seem to be coming first, huh? Again, you have an x that's first, so it's going off the horizontal axis. I like to plot my center and then make a translated axis. I don't work well without something in front of me to guide me. So I like to start like that. I like to put my center, do -3, and just make a translated axis. I also think it helps to put this on here. Because now from your x, you're going over 1, over 1. From your y, you're going up 3. That shows me my 3 is here, my 3 is here. And it's going off of the x again. Yes.
Like when you completed the square and you added the 3, like, constants, like -18 plus 36 plus 9.
Yeah,
9.
-9. Sorry, that's a -9. Because when you distributed this guy out, it's -1 times 9, -9. So you gotta watch that -1. And again, set your asymptotes up and set your little parabolas going. Your equation, you should get better with the equation. What's underneath the y is 9, take the square root, you get 3. What's underneath the x is 1, take the square root, so it's 3 over 1. And move your 3 over. You gotta be careful factoring out that -1. The rule is that the leading coefficient when you complete the square has to be a 1. Now again, if this right-hand side became negative, when I divide by negative, it will cause those two to switch places. So that could happen as well. Good. Alright. And this is the last note too. This one is not a hyperbola. Because even though we start out with an x squared and a y squared and we have a negative in the middle, when we go to complete the square, again you're going to pull out your -9. When you go to complete your square, this piece over here adds up to 0. So there's no way I could get it to be equal to 1. So it's just not a hyperbola. Yeah. I think I took these out of the book, and I don't know if the book did it intentionally or not. This book makes a lot of mistakes. So it was not a hyperbola, but then I decided to keep it because sometimes that happens. Probably because you didn't factor out the -9.
No, I did.
You did? Okay. So then that gets that side equal to 0.
Why is that not hyperbola?
Because I can't get this equal to 1. My format has to say equal to 1. Whether these are whichever way, but it has to be equal to 1. Because it's a 0, I can't get that to be 1. If I multiply anything by 0, I get 0. This just doesn't make me a hyperbola. And the last guy, again, I don't know if the book intentionally did that or just made a mistake. Yes? No, because this, oh, yep. Yep, it would. It would make the 6y positive. It would. So, yeah, you're right there. Thank you. But in the long run, we're still not a hyperbola. But it would.
Where'd you get the low from?
Which, this one? From here.
Oh, never mind. They're still additive.
Good. Okay. And the last one, hopefully this is a Y. Yeah, thankfully this is a Y. Okay, so this time my Y is going to come first. This means I'm going to be, my major axis is going to be my vertical axis. So I'm going off my translated Y axis. Again, find your center. Make your box. You only need to give me the vertices. I don't need the co-vertices, but you do need them to make a box. Again, reduce your radicals. How many radicals reduce? This one too. Just keep everything reduced. When you do your slope, so your asymptotes go like this. See, this is what I was saying when your A and your B changes. Because now A is under the Y and B is under the X. So don't memorize the A and B one. Just memorize it the way your slope goes. Y over X. It's the square root of your Y denominator, square root of your X denominator. So my Y denominator is 2. So I start like this. Radical 2. My X denominator is radical 18. So now, if I put this under 1 radical, this reduces to 1 over 9. That I can take the square root of. Because if you reduce this one and did 3 over radical 2, your radical 2's would come out if you reduced it that way. So therefore, your slope is 1/3. Good. Oh, they're not so bad. I like finding these things. So we're going to find the standard equation of a hyperbola. And the first thing we're going to do is plot what they give us. So the foci is at -1, 2, and at 5, 2. So the foci are on a translated x-axis. So who's going to come first, the x or the y? The x. So I'm going to start like this. Just start this way. Oops. Alright, so now, what can I find from my foci? See, I have to know the center. So can I find the center based on my foci? The average of the x's. So what would that be? -1 plus 5. -1 plus 5 is what? 4. Half of 4 is what? 2. So my center is going to be at 2. 2. Okay, so can I put these in? Good so far? Okay, so what is C? my center is at 2, and I go to 5, C is what? 3. Okay? So good so far. Alright?
What's C?
C is the distance from my center to my foci. And don't forget, my hyperbolas are going to go like this, because they're going to be hooked around this. Not where my vertex is yet. So now I got vertices at 0, 2. This is a vertex, and 4, 2. So now they're going like this somewhere. Agree? Okay, because my foci was inside of there. What does my vertices give me? What letter? A. Okay, so A, if my center here is at 2, 2, and this is at 0, 2, what's A? 2. Can I find B? I have this little sweet formula. So I'm going to put my A squared, and I don't know my B squared, my C squared, and I'm going to find B squared to be 5. All I need is B squared. I don't need to worry about the radical. So now I can replace A squared with 2 squared, and this guy with just 5. So I get x minus 2 over 4 minus y minus 2 squared over 5. There's my equation.
Wait, how did you make any?
A is the distance from the center to the vertex. Oh wait. B is the distance from the center to the covertex, and C is the distance from the center to the foci. Always. How do we know they gave us the vertex? We found the center when we did the foci, because the center, that's confusing because it has a center and it has 2 vertices. So the center is just the center of this box thing. And then all I needed was the equation. We don't have to worry about the asymptotes yet. Okay, one more. Alright, this one's a little trickier. Find the equation who has vertices, and let's start with our vertices. Have 3, 1. This is a vertex. And 3, negative 5. Which is the major axis? The y. Let's go like this. This is the vertex. They're going to have to come off this vertex. Just connect those. The y-axis is your vertical. So y is coming first. A always comes first. I need an A, I need a B, I need a, I don't need a C, but in case I get a C. So what can I tell from this? Center. So it's the average of your x's, which is 3, and it's the average of your y's, which is negative 2. Okay? So now I know where my center is. 3, negative 2. So what is A? That's a negative 2. 3. Okay, so far so good. I know A. 3 squared. Right? Okay, what else did they give me? They gave me asymptotes. Whoa. So they gave me 2 asymptotes. So I can't find my B and I can't find my C. However, from an asymptote, and yes, they worked this whole thing out, what is this guy? Slope. So my slope is equal to change in y over change in x. So this is my y denominator, which is 3, over my x denominator, which I don't know, b. So can I set a ratio up and solve this? So 2b is equal to 3, and b is equal to 3/2. So now, when I square 3/2, I get, this becomes 9, this becomes 9/4, and you just got to flip this over. You got to put 4 on the top. It's like multiplying both top and bottom by 4. So you're going to get y minus, oops, where's our center? Y minus, or y minus 3 squared minus x, oops, sorry, y minus, y plus 2 and x minus 3. This is going to have a 4 here and a 9 here. Because you got to take both of these. Once you square these, flip them over.
How did you find out what
We found our vertices. We found our center, the distance from the center to the vertices. I suggest that you sit with that note sheet in front of you guys. Oh, I think I forgot for this one. Make sure you sit with those note sheets.